Hello everyone. Today my presentation was titled Probing Properties of 6061 aluminum alloys used as cladding for nuclear reactor fuel with X-ray diffraction. This presentation by Mostafa, Minya University, Egypt, with cooperation of Oral Federal University and Egyptian Nuclear Reactor Research and Atomic. Aluminium is the third most abundant element in Earth's crust, and it constitutes 7.3% of the total Earth's mass. The 6,000 alloys are heat treatable and have moderately high strength with excellent corrosion resistance, and it's easy welded. So this type of alloy is serious. The first choice for architectural and structural members where unusual or particular strength or stiffness critically is important. 6061 alloys is the most widely used aluminum alloys. It contains magnesium and silicon as the major elements, as we can see in the presented table in the slide. Application range from transportation components to machinery and equipment, application to leisure products and consumers. The aim of this work is to describe these alloys properties like crystal size, microstrain, defect density, dislocation density, and stored energy using X-ray diffraction device. Methods and investigation strategy. Aluminum alloy 6061 was prepared in dimension 1.4 times 1.3 times 0.4 centimeter using a cut-off machine. The samples were polished and then etching, and the sample should be cleaned after etching with water and dried perfectly. Finally, all samples annealed at 420 degrees Celsius for 2.5 hours. These prepared samples were deformed at room temperature up to 30% of their original thickness using hydraulic pressure. The sample were measured by XRD pattern to present the effect of deformation on the properties of this sample. The intensity change with 2 theta was observed and gave information about the properties of alloys under test. Results and discussions. As in figure, it's XRD pattern of 6061 aluminum alloys. The intensity versus 2 theta are presented in this figure for different deformation. The effect of reduction thickness on the relative intensity of the two peak pattern are presented. As we can observe, this ratio started to decrease 9% of deformation. Also, this ratio increased up to 30% degree of deformation due to preferred orientation occurs. In this slide, figure 2 presents the relative intensity for the first two peaks pattern of aluminum alloy 6061. In y-axis relative intensity, x-axis thickness reduction. As we can see, is the variation of relative intensity with the thickness reduction. For second figure, figure 3, it's crystal size of this alloy with thickness reduction. As we can observe, it's exponentially decrease with increasing in thickness reduction. Figure 4 in this slide presents lattice parameters and microstrain as a function of thickness reduction. We can observe there is not clear effect for the reduction thickness on microstrain and lattice parameter. On the other side, we can see in figure 5 the dislocation density of 6061 aluminum alloys as a function of thickness reduction. We can observe in this relation its increase exponentially with thickness reduction. In this slide of results and discussion, also figure 6, it's defect density with thickness reduction, and figure 7 is stored energy with thickness reduction. Also with thickness reduction increasing to 30%, we observe that defect density and stored energy increasing exponentially like dislocation energy. Conclusion. According to the measurements of the aluminum alloy 6061 by using XRD, we can conclude that the crystal size of 6061 aluminum alloys decrease gradually from 0.388 to 0.075 with thickness reduction from 3% to 30%. Second, the microstrain and LEDs parameter nearly constant for all degree of deformation, only change irregularly, and there is a small peak approximately at 9% of thickness reduction due to the preferred orientation. Dislocation varies exponentially from 9.7 times 10 power 8 to 1.14 10 power 9. Defect density also increase exponentially from 3.39 10 times 16 to 3.99 10 times 10 power 16. From also thickness reduction from 3% to 30%. Stored energy also increase from 36.09 to 42.51 at 3% to 30 deformation. Thanks for your attention, and any questions or anyone want to contact with the authors can be use the email in the first slide. Goodbye.